Morning, everyone. I'm going to talk in the next 10 minutes about how we can use vendor-specific APIs and OpenConfig to build more intelligent and responsive systems. So APIs are not new. I don't need to introduce them. Of course, for the Wi-Fi industry, we have seen a lot more usage of Wi-Fi system APIs, primarily because NetOps and DevOps are becoming more prevalent in the enterprise Wi-Fi networks. And we see broadly 3 use cases of APIs among our customers. So the first typical use case is where you want to extend your existing system, for example, to solve a particular business case where it may not be applicable, for example, to all the customers, maybe 20% of them need it, so you don't want to build them into your user management or network management system. So you could develop a new interface, a new dashboard, or maybe somebody wants a specific type of report to collect data for a particular use case. So as one example, I'll talk about one specific example in the next slide, where we built a new interface using APIs. Second is a more a case where a customer comes up and says, I have this task which I do every day, maybe every week. How do I automate it? I don't need to make 10 clicks every hour, or I don't want to configure the dashboard every hour. How do I make it faster, easier for our team to manage such repetitive tasks? Or I want to do some testing every day, and I don't want to go and click. So this is another example where customers tend to use APIs, to build their own softwares. In some cases, it happens that customer may come and say, I want this, and I say, okay, this will be available only in 6 months' time because I have 10 other things to do. And this is another case where the customer can basically use the APIs to do their own thing without waiting for us to deliver the feature, for example. The third is a more classical software integration case, where you have 2 different systems and you want to glue them together. And that's one case where for example, if you have a third-party NAC system and you have your own Wi-Fi system and you want to use some sort of policy management and have data flow from one system to another, then that case is where you can use the API to bind the 2 systems together. So just to take one example, so in the last few months, we have been working on extending the user interface for basically building a voice-activated system. So the basic framework is very simple. You have a web browser which is running Google Speech API. So when the user speaks, the text gets converted into, the speech gets converted into text through the Google Speech API. And then we interpret that text into a series of API commands which go to our system. And then that system pulls down some data. For example, the user wants to know how many clients are connected at this time. So we pull that data, and then we display it on the UI. And this is primarily to make things a little simpler. Instead of going to a website and then clicking and so on, user can do some simple tasks using this voice interface. So this is one example where we have built an application which is an extension of the typical UI that you see, but it can be run on a separate system. So just to illustrate this, I have a short demo video. Hopefully it will play. It doesn't. Let me try again.
Vani can be used to find out the information.
It doesn't play in full screen. Sorry, guys. It's always something goes wrong with the videos. Okay.
Vani can be used to find out the information about the network health, application performance, etc. This application works across all major mobile platforms.
Has the display gone? Okay, in the interest of time, I might have to skip. Let's come back. My slides are not there. Okay. Okay, I think I'm already halfway through. Let me try again. No. One last attempt. Okay, no problem. Let me go back to the... So, you get the basic idea that what we are trying to do is to sort of, use the APIs both from our system as well as, Google browser APIs to build something which extends the functionality of the interface. The second example is where, we had a customer who was deploying thousands of APIs every week. So this was a pan-India network where, sites were coming up very quickly. And to deploy a site requires a certain level of minimum effort. You have to, provision the APs, you have to configure them. Sometimes the business logic can be very different for different sites. For example, the SSIDs in this case had to be customized because the Wi-Fi was being deployed in colleges. So every college wanted its own, Wi-Fi SSID. So in order to, make the speed of rollout faster, the customer basically built its own deployment portal where the field engineer, once the site is acquired, would simply fill out a form, a plain text form, and that form gets converted into the actionable set of items, which is basically, the entire network gets configured with just a few clicks. So that way, the business logic was made faster by simply using the API-based integration. So APIs can do a lot of stuff, but sometimes we also hit into limitations when it comes to APIs, particularly because when we build those APIs, this is our general purpose interface. We want everybody sort of to be able to use it. A few years back, we had a case where a customer wanted to deploy their own Wi-Fi SON controller to manage how network channels are configured on the APs. And we had our own channel selection algorithm, but the operator wanted some R&D team had built their own channel selection logic, so they wanted to use that in our access points. So in that case, we had to build a proprietary interface to allow them to hook up this SON server to our AP so that they can get data from the APs, use it to figure out which channels to use. So this is one example where we could not do it through API because the customer wanted direct access to the APs to get this data. The other cases where you are looking for information which is beyond what is available in the dashboard. You want more granular information, and you also want to control the rate at which the information comes from the system because of various reasons. So the third case is where you want to basically build a sort of a independent system which can manage the network, right? So there are these use cases where sometimes the APIs fall short, and that is where OpenConfig comes in, right? Because OpenConfig provides a sort of, I would say, standardized way to manage the Wi-Fi access points, right? So the basic architecture is fairly simple. So you have an OpenConfig agent which sits on the APs, and there's a OpenConfig client which sits on the remote server. And these two entities communicate via the GNMI, GNI interface. So you could deploy it in two different modes. So the first case is where you use OpenConfig to manage the entire network. That is, you can configure, you can monitor, you can get the telemetry, and so on. The second case is where you are basically using OpenConfig as a means to stream the telemetry data from the APs. So, for example, we saw in the morning that Peter showed that all this data about how Wi-Fi, the Ethernet data rates evolve as the number of clients changes. So, imagine a customer who wants to read this data and then display it in some, customized dashboard. So OpenConfig provides a way by which you can basically configure these APs to send out this telemetry to a telemetry collector, and then from there on you can use it for multiple purposes. So in this case, the management is happening through the vendor's configuration system, but the other things you can do via OpenConfig. So the question is, why do we need to choose one, right? We have APIs which can do a lot of things. You have OpenConfig which can do a lot of other things also. So our belief is that you should be able to use both these tools or interfaces to build smarter systems. So just to give you one example, imagine a system where you have access points which are configured with OpenConfig support, and the access points are also connected to a network management system built by the vendor. So in this case, the access points are streaming telemetry to the OpenConfig telemetry collector, and then some big data platform is ingesting this data and then storing it in a way in which the anomaly detection system of the vendor can read this data and then figure out if something is wrong or things are working fine. And if something is wrong, then maybe a root cause engine can figure out what is wrong and give you a recommendation of maybe you need to turn down the transmit power, or maybe you are looking at you are having a lot of DFS hits, maybe you need to vacate the channel and start only non-DFS channels. And when such a recommendation comes in, this can be then applied on the access points by using the OpenConfig management interface. So in this way, you can combine the granular telemetry and the granular control on the APs via OpenConfig with all the sophisticated tools that you have in the management system for analyzing the data, for figuring out what is going wrong. And in this way, you can build systems which are more responsive and more intelligent. And this is what I see as the sort of the big picture where you try to see both OpenConfig and vendor-specific APIs working together to basically build better Wi-Fi systems. Thank you. It's my time.